So I figured out my error, and it was a pretty stupid error here. I don't know why this is. I don't want that auto hiding. There we go. If I go to my main.c here, I forgot to start the actual I2C bus. So just like all of our components in our top design, we have to start them. I forgot to start the I2C bus. So of course it's not going to work. And that's why there was nothing happening. So now that, let me go back here. That's not what I want to look at. Close. Let me close some of these things. Go back to the main. So now that I've got the I2C, I was putting this in the loop here just because I was trying to debug it. But so I've started my I2C bus, and now I'm calling the function to start the pressure sensor to read those coefficients in. So now I haven't changed anything else here. I've got these little breakpoints that you can add by clicking on it. And so now I'm going to debug. And we'll be able to see here. And it's going to give me several warnings here. Oh, I also had this flag that I was using to help debug stuff. But I'm not going to do that. I don't need that. So I'm going to go skip ahead to my values here. And it's got flags sitting here because I was using that to read the error codes when I was trying to figure out what the heck I was doing wrong. But what I want to do here is, again, I want to put these both in binary mode here. So we successfully, I'm going to skip to the next one. So we successfully have pointed the pointer and the pressure sensor to the A0 most significant byte. So now I'm going to do one step over here. I sent my restart. So now I'm in read mode. Now I'm going to execute this command, and what we should notice here is data is going to change. Nothing else is going to change yet, but data is going to change. And if I do a step over, we can see here, actually it did two lines at once here. It, for some reason, it didn't execute this line here, but what we can see here is it data read in 01000011. And then it also executed this line of code as well here. So it executed that line of code, and we can see here that it's been bit shifted. It's in the most significant byte portion of A0 data. So it's 01000011. And then these are a whole bunch of zeros here at the end because that's where the least significant byte is going to get read in. So if I do one more step over, it might give it as optimized out, which is fine, but you can see here this is what the other data read in here. There's a way that you can force it to show it. For instance, if we want to just do a stop here, if I put a word volatile, if I spelled it correctly, that basically forces us to always be able to see what's in that data, because basically what it's trying to do here is it's optimizing it so it's not going to show us like intermediate computations or things of that nature. But if I go back and put that as a volatile, skip to my breakpoints here, and then step over slowly. Okay, so I've read in, and it's back to, well, I don't need to leave it there. I can just leave it here. They're doing default, so this is in hex format, so it read in 4.3 hexadecimal. Step over. Now it's storing 4.3 into this A0 data, bit shifted it. So that's in the most significant byte. I'm now going to read in the least significant byte of data. So step over, and we can see I'm reading in E6, and then I'm going to OR that data here. So I'm going to do one more step over, and we can see now it's 4.3 E6. So we can see how we've kind of merged that in there. So now I have the A0 data read in here. And now basically reading in the rest of the data here, I'm going to take out this volatile because we don't need it to be volatile. We want it to be optimized. I'm also going to take out this flag that I don't need. But basically we can say here, well, if I look at my data sheet for this, I was looking up some errors there, error codes. If I look at my data sheet for these variables, let me scroll down here. All the first three are 16-bit variables. Okay, so I can essentially just copy and paste because I don't have to send a restart because remember, the pointer automatically moves to the next location. So I'm going to copy and paste here. But what I'm going to do here is I'm going to be reading in B1. And this would be the most significant byte of B1. And so I have to change a few things here. So instead of it being A0 data, it's going to be B1. And this is going to be B1. And another shortcut you can do is instead of doing the or equals the thing, you can do just like you can do a plus plus, you can do or equals data. So this little here is the same thing as doing B1 data is equal to B1 data ORed with data. Okay, so now I just have to do, I'm going to copy this and paste it again because now I'm just doing B2. So you see, what's kind of nice when you're reading all these coefficients in, you kind of write the code once, and then you're able to kind of, just, actually I should fix these here to make sure my comments are all fixed correctly. And I am going to take this line out. I don't need that comment anymore. So I can basically just kind of copy and paste. Now when we get to C12, we have to be careful here. C12 is only 14 bits. And if you look at C12 here, where's the C12 coefficient? And it's also got decimal point padding. We see that the coefficient for C12 is 0 point bunch of zeros, and then we have 12 bits of data. So the way we're going to read this in is we're still going to read it in the same way. We're going to read it in as 16 bits of data. So I'm going to read it in here as 16 bits of data. But we're going to change one other thing here. We're going to change, first off, we're going to change this one because now I'm done reading data. So I should prepare the I2C bus to stop reading data. So I'm going to do NAC here because I'm saying, okay, I'm done reading data. I've read all the data in. So it's going to be prepared to stop. And before I even do anything else here, before I do any kind of computations, I'm going to go ahead and stop the I2C transfer. And then there's a timeout again, which we'll leave at and 0 for infinite. So this stops the transfer of data here, so that basically the I2C bus gets freed up again so that we could, for instance, communicate to the LCD screen, which we're going to do next week, and do things of that nature. So it's a lot, easier than you think once you start getting used to it. But then we have a problem here. The C12 data is not in the right format. C12 right now is in, if I look at this, the way it would be is it would be in, how many bytes was it? 14 bytes. So we've got 13, 12, 11, 10, 9, 8, 7, 6. Actually, let me do this a little bit better here. So we have C12, C11, or sorry, we're starting with this. C11, C12, it was 14. 14, 13, dot, 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 continuing on to C1, C0. Actually, since it's 14, I should start with 13. I'm sorry about that. So that's what we have. But then we have, because we've read it in as 16 bits, we have 2 additional zeros here. So this isn't correct. We want the zeros, we want these zeros to be over here. So what we're going to do here, it's actually a pretty easy thing to do, is we're going to do C12 data is equal to C12 data. But now we're going to bit shift it 2 spots to the right. So now doing that by bit shifting it 2 spots to the right, I have 0, 0, C13, C12, dot, 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 C1 down to C0. So we had to be a little bit careful there because it's actually only a 14-bit. Now we're ready to do computations because this is just reading in the data. It's unsigned int. So to do the computations here, well, what do we need to do here? Well, first off, let's look back at the data sheet. And we can see here again, for A0, it's got a sign bit. Okay, so the first bit is a sign bit, 12 integers, 3 fractionals. And we already kind of talked about how that would be. So we'd do 2 to the third power. So what I'm going to do here is I'm going to do underscore A0 coefficient is equal to, I'm going to cast this as a float, A0 data. I'm casting it as a float because I'm doing floating point arithmetic, but then I'm going to divide it by, and I'm going to divide it by 8.0, and I have to do it by 8.0 so that it knows that I'm dividing by a floating point number as opposed to an integer. If you just do 8, it's going to treat it as integer division, and you don't want to do that. So I'm casting this integer as a float, and then I'm dividing it by 8 because 2 to the third is 8 to get my decimals correctly. There's other ways you could do it. I find that to be the easiest way. So then I'm going to do B1 coefficient is equal to, I'm going to float, cast my B1 data as a float. And then I'm going to divide it by, well, in this case, I have 13 fractional bits. So I would do 2 to the 13th power, which is 8,192.0. And then the B2 is essentially the same, except 16384. It's got 14. Now for the C12, because of this decimal point padding, we have 9 plus 13, which we talked about in another video. So we have 9 plus 13, which is 22. So you'd have 2 to the 22 power, which is 4,194,304. What was it? 194,304. And I've got some kind of error here. What's going on? I need to make sure this is C12. I must have declared my variable the wrong name in my header. Let's see what I did in my header. Underscore B2, yeah, I left off an F there. So I'll fix that by just putting an additional F. In these here. Okay, so that should fix that. Yeah. All right, so now I've actually got my global variables and I'm done with the star function. Now this is actually the most complicated function here that we're going to do here. So let me save this again and let's go ahead and debug this and see what we got going here. Now I'm going to go ahead and skip here, and I'm going to put in the breakpoint. Let's go ahead and put it in right down here for the where the master is, because we've got a lot of things that we can look at here. Okay, so let's go ahead and go all the way down to there, and we can see we have data being read in for all of these here. We've got, you know, B3E6, which 43E6, which it should be the same. These are factory set coefficients. So the fact that A0 data is the same as what it was at the beginning of the video makes complete sense because these are coefficients factory set. They don't change. Okay, so now I'll step over here and I'm going to, let's see here, let's step over. do one step over there to copy. Now it says optimized out here, which is not the most effective way to see what it is that we have going there. So actually, those aren't the right ones. I need to add watch points to these. So let's see here, memory, registers, what do I want to do? Let me pause a second. There's a way to add additional variables to watch. Okay, it's not that you actually add additional, you can hover over it. And you can hover over it and we can see that my A0 coefficient is 2172.75. Now we can see, does that make sense by going to the data sheet? So, and the way we can do that is they have an example here with some of the, once I find it. Okay, so here they have 2009.75. So I had on mine, if I hover over it, 2172.75. So it's in the same ballpark. If I go to B0, I have 5.437.2 and a bunch of other things. Okay, well theirs is negative. Let me see here. 5.432. So I'm going to need to double check that computation to make sure I'm doing it correctly, because theirs was negative and mine's showing positive. Now B2 hasn't been computed yet, so let's step over that and compute that. We get 2.9, and theirs are negative 2. So there's something going on with our B1 and B2 coefficient computations. And then I'm going to step over the C12, and we get 0.0008. 0.0008. Okay, yeah, so that one's good. But these two here, we've definitely got something wrong with our computations, and it's going to be something with how we're casting these here. So I think what's happening here is I need to, let's stop this here. What I've done here is I've casted the computation as a float, not the actual thing here. So I need to first put parentheses around each one of these here. And it didn't affect A0 and C12 because they were already positive to begin with, so it didn't affect those. But I think I need to put in an additional set of parentheses to first convert these integers, unsigned integers, into floating point numbers, and then it will use the sign byte correctly. So let's program here. Let's debug this again. And let's step here and go all the way down. We'll start stepping over these coefficients. So A0, of course, still the same. Let's see what we get for B1 here. It's still the 5.4, and we got 2.9 still. And of course, we haven't calculated the C12. So, you know, maybe actually, I think I know what the issue is that I shouldn't have had these as unsigned ints. These should just be ints, because there is a sign bit. If I have unsigned int, I'm saying there is no sign bit here. So let's do this now again and rerun it, because I want to make sure that the variables in this. So this is kind of what happens with, you know, APIs here. You got to check your data sheet along with your code to see if it's making sense here. So let's then step over, step over, step over. There we go. You see, now I've traced it back. You see, I was being silly and having those be unsigned ints, and casting it now as an integer. It now uses the sign bit correctly. You can see A0 is going to still be the same, but now I'm getting negative 2.56, and if I go to the data sheet, yes, that matches up nicely with what we have here. And let's look about for the B2 coefficient. Negative 1.06. Which, okay, yeah, that matches up nicely too. That's about 1 as well. So these now match up nicely. So my coefficients match what the data sheet's telling me they should be around. So I know that my start function is working properly. So in the next video here, we're going to actually then write the function to do a pressure reading.